This article is related to numerical investigation of nonlinear vibration in the 2 degree of freedom mechanical system using the MATLAB. In basically 2 degree of freedom means nonlinear mass spring damper system with the harmonic excitation with the time domain simulations which need to be conducted to examine the displacement velocity and energy responses, while the phase portraits illustration illustrate the system's nonlinear motions characteristic. So the frequency domain analysis, including the FFT and steady state frequency response, reveals the resonance behavior and amplitude variations according to the modal analysis, providing the insight into the natural frequencies and the mode shapes. So in the abstract, we have just developed the effect of cubic nonlinear stiffness, which are incorporated to capture the realistic dynamic phenomena demonstrating the interplay between linear and nonlinear contribution in multi-degree of freedom systems. And the results basically provide us the guidance for the design and control of mechanical systems. Also, it exhibits the nonlinear vibrations. It also non-similar normal mode vibrations of the nonlinear systems presented in it. Okay, so these are the abstract with the keyword and the introduction I have just listed. In the introduction, we have just added the nonlinear vibrations of the multi-degree of freedom with the applied mechanics due to its relevance in the designs analysis and the performance of nonlinear vibration observers. This absorbs. Yes. Yes. That basically nonlinear vibration absorbs a multi-degree of freedom. So that's why I have just added. First, we have just considered 2 degree of freedom according to the micro electromechanical systems with short form is called MEMS. Okay, MEMS, and in the MEMS basically these are the flow diagram of two DOF system with the base excitation M1, M2, and these are the K1, K2 basically are the spring constant, and with the C1 and C2 are the it's flow of dynamic behavior. So I have just added its forcing conditions with the energy summary, kinetic energy, potential energy with the total energy as well. So the modal analysis, which also explains the frequency domain, including the fast Fourier transform, including the frequency response function, including f of f, and also the complement time domain studies by identifying dominant frequencies, resonance peaks, and amplitude dependent shifts in the system behavior as well. Okay, so in this work addresses that gap by performing the systematic MATLAB based simulation for a 2 degree of freedom and nonlinear mass springs damper system subjected to harmonic excitation. Like this is the figure of 2 of nonlinear mass spring system, which contains the displacement, velocity, and energy according to the different time nonlinear mass spring system. So here is the importance of 2 system, which is basically 2 degree of freedom systems are fundamental in the study of mechanical vibration. So these vibrations normally covers in aerospace, suspension, automotive system, micro electromechanical systems, called it MEMS. And the limitation of this theory is basically is that we only limit it to the non-linearities. Okay, we are not that linear vibration method. Like for example, limitation of linear theory means it only covers the linear natural frequencies. It does not covers the non-linearities of the spring system, of the dynamic system, of the MEMS system. So that's why we need to cover up. We need to find out the another method which is basically nonlinear dynamic and bifurcation behavior of two DOF system spring resonated in the uh, nonlinear time domain response. So, in the role of time domain analysis, basically the time domain is one of the powerful tools which we study the nonlinear behavior, we study the transient and steady state behavior of the system. We solve the equations of motion numerically. One can obtain displacements, velocity, as well as the acceleration and energy variations over the time. So here is the frequency domain analysis. Yes, frequency domain also highlighted the behavior of frequencies and resonant behavior, and which we have used fast Fourier transform. FFT allows the decomposition of the complex signals into their constituent frequency components. So here is the time domain response summary, which is basically the value of root mean square values. These are the RMS mean, root mean square values, peak values, and the response. Response is basically the coefficients of x and v, okay, in form of v and x. So here is the model analysis. Model analysis also provide us the non-natural frequency with the normalization of mode shape and its mode accordingly. Okay. Now I have used the MATLAB simulation with the numerical simulation system with the parameters of mass, spring, damping coefficients with the force amplitude and phase frequency. So here is the objective of the study and with the problem statement added with the mathematical approach. These are the mathematical equations used in the linear damping and stiffness coefficients with the cubic nonlinear stiffness coefficients. Okay. So here is the methodology. In the methodology, I have just added the complete nonlinear motion and dynamic stability with the response of peak amplitude and the frequency ranges. In the design of MATLAB simulation with the analysis, basically the two DOF system nonlinear spring damper system, which is basically simulated using the MATLAB simulation. Okay, so yes. Next part is yes, these are the output results for the time histories of displacement, velocity, and energies, as well as this is basically the graph displays the phase portraits of each mass, and this graph represents the FFT of displacement of x1. X1 is basically the more amplitude values of frequency. And frequency response is here, steady state amplitude versus frequency. And next one is the modal coordinates according to Q1 and Q2. Okay, so here is the result discussion with the conclusion and references. Okay, so let me just open. Yes, this is the MATLAB demonstration. First of all, I need to just run the whole system and we will get the output results according to the time domain simulation with the frequency domain with the energy calculation and the histogram of FFT and FRF as well. See, these are the output results which I have explained in the article as well. Just check it and you will get the output results. Okay, if you need to ask anything, you just ask me. I will answer your questions. Thank you.